and how Azure can be an extension of your data center. So Windows Azure Storage Services includes several items here. So Blob storage, that's your binary large object storage for unstructured binary text data, binary and text data. So that would be your photos, videos, any unstructured data. Blob storage also includes drives. So those are NTFS volumes, VHDs that you can add to your VMs, and that will show up as a drive letter and extend out the VM. Tables, which is non-relational structured data, not SQL, return messages, and as well as StorSimple hardware appliances. So what does this all mean? So I'm work more on the infrastructure side, so won't get too much into tables and queues, but just so you understand, table is a NoSQL database, it's a non-relational database. It provides structured storage. So table store data as entities. An entity is a collection of named properties and their values, which is similar to a row. As far as the queue storage is a service for storing large numbers of messages that can be accessed anywhere in the world through your basic HTTP protocols. Single queue message can be 64K in size, and a queue can contain millions of messages up to the total capacity of your storage account, which currently is about 200 terabytes. So common uses for a queue, backlog of work to process asynchronously or pass messages from an Azure web role to an Azure worker role. So that's all we'll talk about as far as tables and queues. Now, blobs, that's your storage for your binary and text data, as I said, your message, your video, your pictures, JPEGs, and drives are part of blob storage. Those are your NTFS volumes, and we'll discuss the differences there shortly. So first thing you need to take advantage of Azure Storage is to create a storage account. So your storage account will contain your blob, your tables, your queues, etc., and that will reside in a geographic region. So the storage account represents the highest level of namespace for accessing your storage services, again, up to 200 terabytes per storage account, and I believe currently you can have up to 5 storage accounts per Windows Azure subscription. You can explicitly geolocate to a sub-region or affinity with your storage account. So you would select your region that you would want to store your data. All data, once it's within Azure, gets replicated 2 more times. So you have backup and restore capabilities in case of a disaster. So the storage service, the locally redundant storage provides highly durable and available storage in a single location. Now, with that, you can also have geo-redundant storage, which provides that same durability by seamlessly replicating your data to a secondary location within the same region. So not only will you have 3 copies within a locally redundant data center, you'll have 3 more copies in a geographically dispersed data center. So really take advantage of that full redundancy. And again, in addition to that, not only do you have that geographic redundancy, there are also read access, geographically redundant storage data centers. So up to 24 more data centers spread out throughout the world, and these are your caching locations for your data. And that leads us into, which is the content delivery network for Azure. So this provides you with a global solution for delivering high bandwidth content by caching blobs and static content of your compute instances at these caching locations throughout the world. You can explicitly geolocate to a sub-region, or you can go to all 24 if you like. Real world scenario where you might take advantage of this, say you're doing a live event or a new product launch, and you're expecting high traffic for a short amount of time, you can go ahead and take advantage of the content delivery network to really improve performance for your customers worldwide. Blob storage. So in a nutshell, blob storage is a distributed file system where you can put your files, your unstructured binary or text data, and reach them through your standard web protocols, HTTP, HTTPS, anywhere that you have internet connectivity. So to take advantage of the storage, the first thing you need, as I said, is to create a storage account. Within the storage account, you will create containers, and you think of that as your file structure, as a folder structure. and then within the folders are your actual objects, JPEGs, videos, etc. Now, you can have page blobs and block blobs, and we'll talk about the difference. So a block blob, that's optimized for your streaming workloads, like your videos, as I said. A page blob is going to be your VHD. It's going to be a mountable drive, and that's been optimized for read and write workloads. So leading into drives, the Windows Azure Drive acts as a local NTFS volume that is mounted onto the server file system. Data is written to Windows Azure Drive. It's stored as a page blob, as I mentioned before, and it's defined within the blob service and cached on the local file system. That data is maintained even if that role instance is recycled, because data written to that drive is stored in that page blob. So you have drive durability and persistence in case of any disaster. That drive is persistent and safe. That data is persistent and safe. So, as I mentioned, the drive acts as local drive mounted to the file system. Now I want to talk about a little bit about drive portability. So chances are you have a standard virtual image that you use within your current data center that you would use as a template to create other VMs, for example. You can load that VHD file up into Azure and use that as your template, or better yet, you can also create a standard image within Azure. So Azure has a general library of VM instances, so Windows 2008 R2, Windows 2012, as well as several in Linux instances. So if, let's say, you create a Windows 2012 VM, load it up, configure it to your corporate standards, customize it any way you will, then you would generalize it, so sysprep it basically, shut it down, and use that within Azure to spin up future VMs. That you're not paying for your compute instances for that template because it's shut down, so you're only paying for the storage, which is pennies a month. And you have that drive portability where you can download or upload that VHD as you desire. Now that leads us into a hybrid cloud storage situation, and this is really where most customers are dipping their toes in Azure to use that storage, Azure Cloud Storage, as an extension of their current data center, and store clients that can assist you with that and provide that optimal combination of control and cloud storage. And with that, I'm going to lead over to Jamie with Microsoft.
Cool. Hey, thanks, Steve. Good afternoon, everybody. Hopefully you're all warm. We're sort of passing the baton here, and we're going to. Oh, what happened to our presentation?
Oh, sorry.
It's okay. Bring that back, because I think. Do me a favor. I'm going to let you drive slides, and I'll talk, and we'll figure out how to make this work seamlessly. As Steve mentioned, my name is Jamie Peebles. I'm a hybrid cloud storage specialist for Microsoft. I basically am the lead engineer in the Midwest district for Microsoft on StorSimple. And what we're going to do is sort of take the concept of blob storage that Steve was mentioning earlier, the big sets of unstructured data that you have in your environments, and talk about a specific solution that Microsoft acquired about 14 months ago, this company called StorSimple, that really has an interesting approach to storage in general. I missed the beginning of this dialogue. I apologize. I was stuck on a different meeting. But I will go ahead and invite anyone who has questions along the way to just drop them into the chat window. I'll do my level best to address them as we go through. If I ignore your question, it might be because we're going to get to it a little bit point in time later. But I'm a big believer in context-sensitive questions, so don't be shy. That said, when you talk to people about storage, well, I should say most people, when they think about storage, are typically gravitating to the left side of this slide, where we think about primary storage. Where do I keep my stuff? But storage in and of itself is encompasses a much larger portion of the conversation. It's primary storage, It's also archival storage. It's backup storage. It's tape if you're doing that. And it may even be replicas for off-site DR purposes. All of these things require complex efforts, and they're expensive. So if we look at what the storage options are, it's usually buy more of all of this, or we can take a different approach, which is essentially this cloud integrated storage solution that we're offering up as StorSimple. I will admit that when I first saw this slide, and I'm a technical guy, I saw the 60 to 80% lower TCO and said, all right, that doesn't pass the sniff test. I'm dispensing that as marketing. We'll get to the bottom of this at the end of the presentation, and I'll actually show you how those numbers actually vet out. But essentially what we do is we mitigate the complexity that's introduced at the bottom of this slide and take a different approach where we integrate the cloud with your storage infrastructure. And so I don't know how to, can I advance these myself, or I'll just go next slide and we'll bounce towards it. What we actually do is replace all of that infrastructure that you saw on the previous slide with an appliance-based model, and academically this is a SAN. It's not a NAS because it does talk the iSCSI protocol, but we put this device in between your application servers, and it functions as a large-scale, almost you could think of this as an iSCSI target combined with an internet cache. And one of the things that we want to do with this solution, and one of the things that distinguishes itself, is that we bring a couple of very unique offerings to the conversation. Number one, we're going to take the most active data and put that on an SSD tier on this device. As that device fills with data, we will move the least active or the less active data to a SAS tier. So we've got integrated tiering. We're also going to do deduplication and compression on this data in a block level format. And as the device further fills, eventually you will have cold data that you would like to move to what would normally be a third tier of data. In this situation, we're not using a third tier of storage. We're actually using Blob storage in the Windows Azure cloud. And Blob storage is just binary large objects, so you can just think of this as big chunks of disk sitting out in Azure. And this is a really interesting way to create what might be thought of as a bottomless file server for long-term retention, archive, and backup. Now, the other thing that's interesting, you might say, okay, great, you've got this really sort of elastic SAN. I would maintain that the more compelling argument or rationalization for this device is not the fact that it has hordes of capacity, but rather that with the snapshot technology that gets introduced here, we can dramatically shift the conversation around how you're doing backup today, not only from a cost perspective, but also from a time perspective. And we do what are called snapshots. We can do local snapshots where the information lives on the device, or we can do remote snapshots or cloud snapshots. And combined, this is where we get to that 60 to 80%. So let's go ahead and take a look at what this means. This is sort of the tiering mechanism, and we'll need to build one more of this. But essentially what happens with a normal storage array is that your data will grow continually over time. And this is that exponential hockey curve type growth that we see with the traditional storage models. It contributes to not only an operational expense, but also a capital expense because you're always buying disk. With StorSimple, what we do is we essentially take that working set of data and leave it local, but we'll move the colder set of data out to I'm getting control. Cool. We'll move that cold set of data out to another tier of storage, which is ultimately the cloud. So if we go ahead and build this one, and I don't know, can I just click, make that go? No.
You have control, Jim?
I'm looking, trying to figure out how. Bear with us for a moment while we figure out how to work remotely. No, I don't think so. I am currently presenting. There we go. I'll just have you keep pushing buttons.
That's fine.
The real target use cases for this are listed here on the right-hand side of the screen. And you might be looking, some of you may be thinking about, okay, Jamie, this sounds great. It's almost too good to be true. You've already gone 60 to 80%. You've said we've got this bottomless server that has immense capacity. That's great. That's big print. Where's the little print? What do I need to be careful for? The target use cases for this are file shares, large file servers, NAS boxes, CIFs, and even NFS volumes, where I do have large sets of stale data. One of the really good self-deprecating examples that I give to people is the fact that I have all of the performance reviews that I have ever gone through in my 13-year career at Microsoft saved on my redirected My Documents. If somebody told me that data retention policies say that you can only have the last 2 years of data, I would find a place to put the 11 other copies of my performance review, because those are important to me. I probably haven't accessed any of those in the last 18 months, but save for the last one. But that notwithstanding, I don't want to get rid of that data, and so that's where some of this cold tiering would exist. We see a lot of this in sort of SharePoint implementations where people will start a project, they'll have lots of information, and then they need to, for some reason or another, retain that for large periods of time. Archival solutions are a fantastic use case for this situation. We've worked with a number of manufacturing companies that are saving their engineering records, a lot of their documentation on either older parts, older projects, whatnot, logs, records. You can read the slide here. Another really great use case that we've seen a lot of uptake on is in the legal community on litigation archiving. And finally, you'll notice at the bottom of the list we have VMs with the ever-present asterisk. VMs are interesting only because we start getting into a little bit of a situation where we need to be careful. The piece here is VMs for archiving, and it's archival VMs. We have a case study with BMC software, and BMC uses VM snapshots for their change control mechanisms as part of their software development. They do a snapshot of their VM, and they store that on the StorSimple solution. If you're doing virtual machines today, and most people are virtualizing some of their infrastructure, you'll know that a lot of those VMs have significant requirements around disk performance. The disk performance characteristics on a 12-spindle unit that we're talking about here today, and we have a larger one that has 24 spindles, is not necessarily as good as you might expect. It's not a high-performance storage array, and it's not intended to be that. And so when we say VMs, I run my VMs in my demonstration environment and my lab environment on the solution, and it's fine. But if you're thinking about, well, gee whiz, does this mean that I could put a large SQL cluster? I would say no, thank you. And the reason for that is you're just not going to get the disk I/O out of the solution that you need. There are other solutions that can solve that problem. This is not one of them. My tagline here is that the StorSimple solution does a really good job of solving your dollar per terabyte problem. It's not necessarily well suited for solving your dollar per IOP problem. That notwithstanding, we still have a tremendous amount of opportunity for, again, file shares, archives, SharePoint, and some VMs. So if we go to the next slide and take a look at where some of this has already been implemented, there's a couple of case studies, and actually there's 4 case studies here. None of these are necessarily public, so I can't share with you the names of these companies, but I can tell you that they are large Fortune 1000 companies. We've got an office products manufacturer that has about 40 SharePoint databases. Their SharePoint databases were expanding because, as you know, SharePoint takes and ingests a lot of content. With SharePoint and StorSimple, we have the ability to take some of that data content or some of the content out of the SharePoint database and move it over into a file server repository using a technology called remote blob storage, or RBS. We can marry that up with StorSimple and get much faster performance out of the SQL database because now it's not clogged up with all this content. We also have some really interesting stories around backup recovery and DR. There's a semiconductor vendor mentioned in the upper right. They had about 1 or 2 terabytes per month of growth at one location. They were doing a lot of engineering and chip design documentation. They actually moved a lot of that older, stale data, and if you recall back, there was that hockey curve growth, or hockey stick growth curve with that stale data towards the top end of the spectrum. They moved all this off to the cloud. They do backups and recovery with these cloud snapshots that we'll talk about in a moment, and saw dramatic cost savings with no changes to their applications. Because again, this is just presenting storage at a one level. The applications are completely ignorant to the fact that we're introducing the cloud as part of that component. Now, there's a global food company that had a lot of VMs. Again, stale data. You talk to VM administrators, and a lot of you ask them, well, what's your backup and restore strategy? And they would say, well, we just take snapshots. And when you start thinking about putting snapshots onto these really expensive EMC arrays, it drives the cost of virtualization up in a way that people don't necessarily care for it at the financial level. This was also their first usage of iSCSI, as they were previously using 8 gigabit fiber channel. One of the things that, if you're looking to drive cost out of the equation, HBAs are really expensive. Fiber channel infrastructure is really expensive. If we can use commodity networking device that's already in-house, there's a further opportunity for savings. And then finally, there's an insurance company that's using this solution for a lot of use cases, specifically file shares. This one in particular is moving all of their storage in their primary data centers to the cloud. They estimate that they will get to 500 petabytes of data in the cloud in the next 3 to 4 years. So tons and tons of information that's just candidly been on paper and expensive disk for long periods of time. We go ahead and move to the next slide. We could talk a little bit about what's actually happening. Oh, sorry, I skipped a slide. Here's some storage analyst perspectives. This is not just me saying, hey, guess what? We've got some really big customers that are doing this, but in fact, some storage people have taken a look at this in the analyst community. One of my favorite quotes is from ESG. StorSimple is a notable early innovator in this market. In this market, the Taneja group also has taken a look at this, and at the forefront today is clearly StorSimple. So this is leading edge sort of thought processes. It is definitely a paradigm shift. There's a fantastic book that I think we can follow up with as an ebook to this discussion that sort of takes you through the concept of rethinking enterprise storage. And I'll commit to Ryan and Steve to get you guys a link to that so that you can take a look at it. It's about a 90-page read. It's a good airplane book for those of you who travel. It's also fairly easy to read. It's not deep technical, but certainly an interesting approach from a strategy standpoint. If we go ahead and look at the next slide, I think we'll get into a little bit of what this thing actually is. Here on the left, you'll see a picture of it. It's ironically it's white. It's real easy to find in the data center, but it's manufactured by a company that does a lot of device manufacturing for other OEM vendors. The company that makes this is a company called Xyratex. They also make storage arrays for Hitachi, Dell, Compellent, and others. But at the end of the day, this is an iSCSI SAN that has auto-tiering between solid-state drives and SAS drives. It has the ability to do automated snapshots on a scheduled basis and with policies that you define. And also performs inline deduplication and compression across those two tiers of solid-state and SAS drives. The cloud component comes in because as we run out of space, we need a repository for those additional blocks of compressed and deduplicated data, and that information lives out in the Azure cloud along with a replica copy of what we call a metadata map, and that metadata map is the component that sort of is responsible for tracking all of these blocks of data and understanding how to reassemble the information and present it back to a front-level file server. This is it's a certified platform on not only Microsoft Windows Server but also VMware, and it has full redundancy not only at the disk layer through various RAID algorithms, but also on the back of this, which I don't think we have a picture of. We have redundant power supplies, redundant networking, redundant controllers, and it is a fully redundant system in, as you can see here, or you might be able to tell, a 2U or optionally a 4U package. So again, lots and lots of capability in a very small box. The one piece that I left off, and I should have mentioned this earlier, I apologize, but you'll notice the top bullet point on the right-hand side of this slide. There's also a security component here that most people wonder about when it comes to cloud. The device itself, when it moves data to the cloud, encrypts that data with a 256-bit key that is built off of an algorithm that you control, not us. I like to tell people that the next time that the NSA wants to look at their data, your data, they need to ask you, not me, or anybody else at Microsoft, because we can't possibly begin to help them because the data has been encrypted by something that we don't have any control over. And so that has a tendency to address a lot of concerns that people have about, okay, I like the fact that you can put my data in the cloud, but I'm really not quite sure I'm ready to go all in. How do I keep it and make sure that it's mine? And the answer to that is the fact that we do, in fact, encrypt that data fully. I'm looking at the question queue. I don't see a whole lot, so I'm going to go ahead and continue. We'll talk a little bit about, oh, here's one. All right, so Greg, thanks. You're the first winner. I don't have anything to give you. I apologize. Does the encryption carry over when the data is moved to the cloud? The encryption actually happens as the device moves data to the cloud. It's not encrypted on the box. Again, this is block level data. So the encryption happens at the cloud level, or I should say on egress of the box and ingress to the cloud. It can be further encrypted at a file level if you should choose to do that in advance of it ever hitting the box. And it's also important to note that it's encrypted in flight with SSL to the data center. Greg, you get a $10 gift card to cover lunch. Nice. All right, Ryan, thanks a lot. Other questions? I'm sure I'll keep an eye down there. We'll talk a little bit about what is my favorite capacity when it comes to this solution, and it has to do with the disaster recoveries component. If we look at this simplistic diagram, we might have a production data center in what we'll call data center 1. You put a bunch of servers in front of this unit and connect them with an iSCSI initiator. The device is serving data and either spilling that third tier of data to the cloud for capacity purposes, or by default, we take a snapshot of that data once every day and upload it to the cloud. If that data center were to go down, we have the ability to rapidly recover any of the information to another box or another appliance anywhere in the world, and the only requirement is that we have an internet connection to that system. Now this is a site failure. If you could say, well, gee whiz, if I have two machines in the same site, but the idea here is that, as I was mentioning earlier, we've got redundancies built in at the power, the networking, and the controller levels, along with the disk level on the system. But if the whole building goes away, I still have a snapshot of my data in the Azure Data Center in an encrypted format that I can go ahead and rapidly access. And now that rapid access is interesting because it's not your typical data recovery exercise. And if we go to the next slide, you might see, I think we've got a detail here that talks about what actually happens. The top of this is your typical workflow for disaster recovery today. You'll have a primary volume, you take a snapshot, you might move it to a VTL that could be on-site or replicated off-site, and then that information may be put on physical tape and taken to an off-site location. With StorSimple, we'll take that primary volume that lives on the unit. We can have local copies, local snapshots of that data, retained more frequently than once a day, so that we have those very short recovery point objectives. And then as changes are made to the local volume, they're automatically transferred up through that snapshotting technology. We can also do those daily cloud snapshots, as we were talking about a moment ago, to simplify that off-site scenario. And so now, if we look at, contrasting the top and the bottom of the slide, we'll have local snapshots for rapid data, and we'll have cloud snapshots for DR recoverability purposes. If we go ahead and advance the slide, I think we've got one more build here. Just some benefits. This gives you the opportunity to truly eliminate tape in your environment. So think about that for a minute. Most people are spending significant amounts of money in their tape backup or their DR strategies. The benefit here is that we're using the cloud for that redundant backup facility as well as that archival component. This is a graph that shows the application recovery times from offsite backups in a disaster with 3 popular approaches. One of them is the red line, and you'll notice the scale here on the left is logarithmic. It's not linear. But if I need to recover let's say a terabyte of data from tape, I'm looking at, in a disaster scenario, the process of actually getting that tape from an offsite facility, bringing it back somewhere that it can be recovered, potentially procuring new hardware, again, in the sense of a disaster. All of these things, or maybe not, right? It may just take me that long to get that information back, but it's going to be a healthy exercise nonetheless. If I do a regular cloud backup with a 100 megabit per second WAN link, the amount of time that it will take me to download a terabyte of data is roughly a day. The StorSimple approach is different. Our approach basically goes out and gets a copy of the metadata map. Not the data itself, but just a representation of that data, which is somewhere in the neighborhood of 0.3% of the total volume size, which allows me, with a WAN link of half of what the blue line is represented by, so I'm a 50 meg WAN link, I can get a terabyte of data back in about 15 minutes. Now, that's not fully true. If we're not getting the data, we're just getting the representation of the data. And then as people access that data, or as applications access that data, it will be returned in block format from the cloud on an as-needed basis. So there's a question in the IM window. Does the DR or failover come with a basic license? Can you please provide licensing information in detail? Sure, no problem. We'll get to the end of that. We'll absolutely hit that one on the end. And if I don't get to your question, you call me out and I'll make sure that we do get it addressed. The way that this is licensed, and the short answer to your question is, this is technology that's built into this storage appliance. Let's call it a SAN. It's part of the SAN software. There's no the licensing of this is really, really easy. It's all based on Azure consumption, which again we'll drill into in a little bit more detail. But the short answer to your question is yes. All of this that we're talking about comes with the basic license. There's only one license, and it's basically how you consume Azure. So is this a SAN? Yes, academically it is a SAN. It is talking iSCSI protocol, it is, as opposed to a NAS, which would talk CIFS. But it is a SAN. I would think it's not necessarily what you might consider to be a SAN if you're looking at the normal implementation of just a refrigerator of disks. But in that it's much smaller and we don't need all those disks because we're using the cloud. But yes, it is a storage area network. I'm looking for more questions. No one's typing. Let's keep moving. So at the outset of this conversation, we said, what I made the claim these 60 to 80% savings. How do we get there? This is a diagram that represents what you might look at. And this is typical and I should say, it is a potential deployment. Your mileage may vary. This is not representative of any specific customer, but this is high-level overview of where we come up with these numbers. If I have a traditional disk array for 50 terabyte workload, I may spend $100,000 on that. And that disk array may be duplicated if it's replicated somewhere else, if I'm doing those snapshots elsewhere. I may have a media server at 25K that's performing backup responsibilities or presenting out a virtual tape library to another set of disks with additional expenses. I might want to encrypt that backup information and put it on a physical tape and then take it to an off-site vault. If I add all of this up, capital expenditure, I'm looking at about $375,000 a year with support costs of another $75K. If I contrast that 50 terabyte workload with the StorSimple approach, I'm essentially putting the StorSimple implementation in the middle with a primary volume and local snapshots for backup. And then I'm doing cloud snapshots and clones to nearby clouds and remote locations. I don't have to spend anything from a CapEx. There are support and cloud costs of $55,000 per year. But if I take and add those up across a 3-year period, and you're like, okay, there's lots of numbers here. I need my spreadsheet. Fear not, because next slide, we've got a tabular view of exactly this pictorial representation, which essentially says on the left-hand side, here's where we come up with our $375K. Our support costs at 20% per year, $75,000, 3 years, $225. If we add that up, obviously there's no cloud costs in the traditional storage model. We're looking at a 3-year customer cost of $600,000. With StorSimple, there's our little friendly asterisk at the top. We'll talk about that in a moment. There is nothing to buy from an equipment standpoint. So there's no capital expenditure. There are some support costs that we'll throw in. We'll call that $5,000 a year, and a cloud storage cost of $150,000. And so that gets us to $165. And if we divide 165 by 600, you'll see some compelling numbers. I want to address the asterisk here first. The asterisk is based on an Azure storage promotion that Microsoft is conducting through the end of our fiscal year. So we end in June. So from now until the end of June, you can basically sign up, and this gets to the licensing questions that were addressed or asked earlier. If you make a commitment to Windows Azure, you basically sign a contract that says, we want to sign up for $50,000 of Windows Azure, Microsoft will give you one of these appliances. So you say, we want $50K, and we'll pay $50K, and it's kind of like a prepaid phone card or a debit card that you might experience in Starbucks. You go in, you give $50,000, and they say, you know what, we're going to give you a mug to drink for no charge, and then you can come back and fill your coffee mug for as long as you want for $50,000. Now, the question that sometimes, or I should say frequently comes up is, okay, that sounds great, Jamie, but how much is the storage cost? Am I $50,000 for 2 terabytes, or is it $50,000 for 80 terabytes? There are some pricing calculators that live on the Azure, the WindowsAzure.com website. I will tell you that the list price, and nobody pays list, is 9 cents per gigabyte per month. So again, your amount of storage will be dependent upon how much you're actually putting in the cloud. I will also tell you that I have yet to see anybody that I have worked with consume more than 40% of that initial Azure outlay on storage. And the reason for this is that Microsoft's business goal is to get people to adopt the Azure cloud in as much and as many ways as possible. Our hope is that you'll get all your storage there with the storage appliance, and you'll have some left over to do some interesting things like Active Directory domain controllers for offsite, or maybe just a dev test environment, or maybe you want to do federation services with Office 365. What better place to put your federation server than actually in the cloud? There are a number of really, really compelling Azure use cases which we're not going to be able to get into today. But the nice part about taking this approach is that you'll have those additional funds to be able to do all of those other really interesting and compelling business solutions in Azure as part of this acquisition cost. Now, we could have turned these numbers around and said, you know what, your cost for StorSimple, let's just say you're going to spend 50 grand on the appliance, and now your cloud storage costs are 100,000. Or maybe you can make those math numbers work out. The important thing to note is that the bottom line numbers never change. It's 600 versus 165. And that's where we get that dramatic TCO savings that I mentioned early on. Looking at the question queue again, so do you have to allocate space or LUNs in order to get Snapshots backups to work? Yes. You would create a LUN or multiple LUNs. So another good question there. The LUNs have, you can put an organized LUNs into what we call volume access groups, and then we would apply a snapshot policy to those groups for consistency purposes, so that you could essentially take your cloud snaps across multiple different schedules. Your snapshot policies essentially become what most people consider a tape rotation policy to resemble. So I might do a daily cloud snapshot and have retention periods of 28 days. I would also have a weekly cloud snapshot with 52 retention cycles, and then a monthly cloud snap with 36, and now I have essentially the ability to say I have 3 years of snapshots. The nice part about these snapshots is that they are deltas, so I'm not replicating all of the data into the Azure cloud. We're actually doing what you can think of as a full running incremental snap across these blocks, so that we're not chewing up those storage costs for the purposes of just running the meter up. So here's just a summary screen. We've got one more question. What kind of support does it come with? Is there a limitation on data storage? Wow, you got lots of questions here. This is good. So let's take them one at a time. What kind of support does it come with? There are 2 levels of support, Gold and Platinum. The differentiation between those two primarily is the fact that with Platinum support, you'll get an on-site spares kit, a spare hard drive, a spare SSD, a spare SAS drive, a spare controller, spare power supplies, spare batteries. Those are all user-changeable parts and pieces. My mother is getting along in years. She's in her 70s. I don't think she can fax. I have every belief in the world that she could go ahead and do any serviceability of this unit. It's that easy. There's alerting mechanisms that tell you what to do. So that would be your support options. Is there a limitation on data storage? I'm not sure I understand the question around data storage limitations. I presume it's based on the type of content that you can put here. The answer is no. It's, at the end of the day, it's a LUN. You can put whatever you want on it. If I missed the question, go ahead and clarify, and I'll try and get that straightened out. Also, please correct me if I'm wrong. Based on your presentation, looks like as you grow, buy more storage. Is that correct? No. As you grow, that's certainly an option, but ideally, I shouldn't answer your question so quickly. The additional storage requirements are only necessary based on your daily change rate. We want to be able to service the data sets in a way that that allow for the unit to have enough of the working set of data on the device. And the devices come in three primary sizes. We can think of them as t-shirt sizes, small, medium, and large, or they'll hold anywhere between 10 and 100 terabytes of information locally. Obviously, the decision to put a specific unit from a sizing standpoint into your environment is going to be based on how much local capacity that you will need, and that local capacity is going to be dictated by your working set of data. If you run a small printing shop, you'll have probably a lot less change rate than if you were doing digital advertising or something that has a much higher churn. So again, it's very much an it depends answer, but typically what drives an additional unit is, as I mentioned earlier, IOPS and not necessarily capacity, because the capacity can be addressed from the cloud. I see you typing. I will wait. Anybody else have any questions? All right. So this is where we sort of come back and circle back with the guys from Netrix. I will continue to monitor the question queue, but hopefully this piques your interest. If there's more that we could present, by all means let us know. I'll be happy to come out and we can do a whiteboard session or demonstrations as you so sees fit. With that, I'm going to give it the talking stick back to Steve and let him bring us home. Steve,
okay. Got it. Thanks, Jamie. So really quickly, what can you as the customer do to take advantage of Azure and moving forward, maybe get into a pilot environment? So really quickly, just give you a brief rundown of who Netrix is. We've been around for over 20 years. Specialize in delivery of network infrastructure, security, system services, unified communications, cloud services, managed services, et cetera. Consistently ranked on the VAR 500. We work with a lot of Fortune 500 firms, government organizations, global organizations. But more importantly, we want to be your trusted advisor and your subject matter expert when it comes to all things cloud. So please feel free to reach out to us and let's discuss what you can do next. We can work with you to create a roadmap, talk about ROI, any success criteria and business drivers that would need to be met in order to make this feasible for you. We can talk about extending out your AD out to the Azure cloud, configuring federation for Office 365 for Azure, and really extending out your data center out to the cloud. We can talk about a fast track a pilot. Now, if you're an enterprise customer, you may have Microsoft dollars available to you to run through a pilot, to run through a deliverable stage, and we can work with you to find out what is available to you, and that may not cost you a cent to run through this pilot. Not only can we do Azure, we'll do Office 365, anything cloud related in the Microsoft stack. So an example here is this a data center that has been extended out to the cloud. So there's servers within the corporate network, the perimeter network, as well as VMs out in Azure, and the cost ends up being very reasonable. As Jamie said, go out to windowsazure.com. There's a pricing calculator that'll give you at least an idea of what it would cost to build out VM, storage, bandwidth, and you can see where you would stand for what you would need to put out in the cloud. Really quickly, we'll be doing these conversations every month. So next month, we'll talk about SharePoint and SQL services out in Azure. So definitely sign up and come back, and we'll discuss any other needs you may have. And I want to leave you with my contact information if there's any questions that we didn't get to in the queue. And with that, thank you for attending.
Thank you, everyone. We'll make this recording available on our website as part of our monthly series talking about Azure. This is the third of 6 in the series. Have a great day, everybody.